Hello, good morning, friends. My name is Suhas Vora, Electrical Department at the Sri Swaminarayan Institute of Technology. In the previous topic, we can discuss about the power frequency heating. Now, the today's topic is the high frequency heating. So, first of all, we can think about the what is the difference between the power frequency and the high frequency heating. In the power frequency heating is the heat is transferred either by the conductions or the radiations, but in the high frequency method the electromagnetic energy converted into the heat energy inside them. The high frequency heating can be applied for the two types of material. The material name is the ferromagnetic and the non-ferromagnetic, and this is known as the induction heating. This process of the heating of the insulating material is known as the dielectric heating. So first of all, induction heating. So basic principle of the induction heating is used for the heating charge. Charge means the which material you can melt. The heat energy is transferred to the charge at an extremely rapid rate, much faster than other conventional method. The classifications of the induction heating is the direct core type, vertical core type, and induction core type. So first of all, the directional core type. So in the directional core type furnace is essentially the transformer in which the charge to be heated from the singleton secondary circuit and is magnetically coupled to the primary by and the iron core. You can see the figures here. The one transformer limb is connected from the power supply. The power supply is AC or DC both, and the secondary side is connected to the charge, which material is put in the metallic charge or the cubicle. So main the operations of, you can say, the second number figures. The basic functions of this is we can given the power supply in the primary side, and this limb is heated with the secondary side, and the charge will be melt up. So this one is the basic of the direct core type uh, heating. Now the next one is the vertical core type furnace. So vertical core type furnace is also known as the Ajax Watt induction furnaces. So what happened in the vertical core type furnaces, you can see the figures. It basic consists of the transformer with the horizontal core and the vertical channel of the charge. The secondary is formed by the charge itself. Comparatively, the better magnetic coupling between the primary and the secondary is obtained due to the V shape. So the odd shaped cubicle is avoided. In the upper portions, inlet is provided for the charge and the outlet for the pouring the molten metal is also provided. So what is the operation? You can see the figures number B. The V-shaped channel is always fit with the molten metal. The total metal is never drained out from the furnace. It means that you can see that the V shape in the filled with the molded and covered with the materials of the outer surface. So even if the furnace is not functioning, a low voltage is maintained across the primary with the help of the auto transformer, which circulates the current and thus keeping the charge in the molten stage. Now the additional charge to be melted is powered in the furnace. The primary is given of the AC supply causing the heavy current in the material housed in the V channel. Thus heat is produced which is utilized for the melting the charge, and the circulations of the molten metal take place in the V channel. So we can easily understand about the V shape of the HX Watt induction furnaces. It is the fully with the covered and the safe for the others the induction furnaces. And the next one is the indirect core type furnaces. So how it's work in direct core type furnaces, it work on the principle of the transformer. We know that this the functions of the transformer. The primary winding is wound on the furnace and it is connected to the AC supply, and the secondary side will be charge connected in the charge, so that if we can given to the primary side heating AC or DC supply, and the secondary side will be heated and the charge will be melted. It means that due to the skin effect, the primary winding gets the heated up to keep the coil temperature within the limits. These coils are made hollow or water is circulated through it. The heat in the charge is produced by the eddy current following the concentrically. The high frequency supply is preferred 500 to the 1000 Hz because the eddy current is directly proportional to the frequency squares and the b squares. It means the flux densities. So how is the advantages of the indirect core type furnaces is the time required from the melting is less, the temperature control is easy, and overall cost is less. So thank you. If any doubts of this topic, you can give it to the message, and also subscribe the my channel's SSIT part. Thank you.